When designing an ADT, abstract data container, we have a choice about how to handle the elements. Either we handle them by making a copy of them or by making a reference of them before passing them around. So let's talk about the very first approach, by copy. This is when we have to make a copy of the object or data used in the client program. And this data could be an array of elements or it can be an object of objects. There are two approaches in this regard. The very first one is what we call shallow copy approach, which involves copying property values. Therefore, the copy may be dependent on the original object. The other copy approach is what we call deep copy. All of the objects in the trees are deeply copied, so the copy isn't dependent on any earlier existing object that might change. The problem with shallow copy is that we are only copying several properties or some properties of an object to another, leaving the rest of it unchanged. And that is definitely not what we do when maintaining the integrity of all of the elements inside the ADT. Therefore, we would opt for what we call deep copy, which recursively iterates through all of the objects and their nested objects, trying to copy everything inside of each object. This is a very intensive task. Normally, you wouldn't want to write your ADT to involve this layer of complexity. When we're dealing with Java object, we can also enable each object clonable interface. And since every object in Java inherits from Java len object, we can use the clone interface to efficiently make a copy of the object. This means that if you want to make an element copy, you would simply involve this element object clone method to copy it. There's a couple of assumptions here. One, we're assuming that this element, which is an object, has a rigorous cloning facilities, meaning that we sometimes have to overwrite an object's clonable interface to ensure that we are really copying every single field and properties of an object to another. Without this assumption, you can't simply use .clone on every single object to expect that the entirety of your object is being passed. The other problem about this clone method is sometimes you do not own an object. Let's say if this object is owned by another program where you don't really have access to, so you can't overwrite its clone method. This creates a lot of problem because you won't be able to completely deep copy that object. And overriding the clone methods is not as simple as writing a whole bunch of conditionals to copy every single field, but sometimes it might involve creating additional constructors or implementing the clone methods on all of the classes in the object graph. And that is if an object has nested objects, which have nested objects, so on and so forth. And really at that point, we might as well serialize the entire object and then deserialize it to a new object. So there's a lot of ways in Java to make a copy of an object, but none of this is easy. The other approach for handling elements is to pass everything by reference, or you can manipulate this object reference instead of dealing with making a copy of it. So what a reference is simply an alias to an object. So you can think of a reference holding a memory address of the original object. So really, when you're dealing with references, you're dealing with the original object. This is the most commonly used approach in ADT when we handle elements. And in fact, this is the approach that we will use in code to illustrate ADTs. Here are some of the drawbacks regarding deep copying data for use with ADT. The first one is the current status of the object. Sometimes objects change from time to time. Making a copy of the object reflects the current status of that original object. However, if this current status or the snapshot of that object may change in the next time frame. So here's a drawback of that. And the other one is really about time, because deep copying sometimes evolves recursive or iterations to get all of the fields and properties copied from one end to the other. And you will end up with lots of copies of objects, which also require memory. Let's, in comparison, look at by reference. Making a reference of data inside ADT is a lot more attractive for reasons that, first, you don't have to make extra copies or go through these rigorous copying mechanism to make a copy of something because you are simply referencing the original object. So whatever you do to the data inside ADT, the effect of those changes remain. And remember, reference is about making an alias of original elements. Therefore, we must deal with the potential problems of associating with aliases. And the drawback for dealing with references is that sometimes you could have a business logic that inadvertently changes an attribute or properties or something about an element. So the integrity of the elements held by ADT is forever changed unknowingly. Therefore, passing by reference has risks. And to mitigate those risks, the handling of elements by references are one, protected, meaning you don't want to expose your references to the outside world so that an attacker can come in there and make changes to it, tampering your data. Two, you must ensure that the data sitting inside your ADT are utilized and updated or deleted only by trusted methods inside the ADT. And you must have test regressions and unit tests to ensure that these transformers won't tamper the integrity of your elements. Let's go through an example illustrating copying versus reference. Let's say we have 3 objects in this world, 3 persons. Each person has a name and weight. Our underlying data structure is a list, which is an array with n number of elements. We will store these 3 objects into this list with example number 1 by making a copy of 3 objects into the list. So this is the copy route. The second one is we will create references of the 3 objects and store into another instance of the list by reference and compare the efficacy of the 2. The comparisons involves making one change to one of the original objects. We'll see the effect of that change object has on the underlying data structure. And this list is the same as an array in some other languages. We have 3 objects, S1, S2, and S3 on both sides. They're both the same. And we have underlying data structure called list for both. Doug has a weight of 230 pounds, Jane 120 pounds, Jen 127 pounds. These 3 objects are the same. Let's add these objects into the list respectively in the next slide. In the copy approach on the left side, we're making a copy of S1, S2, and S3 and push them to the list. And then we sort these 3 objects by their weight number. So the lowest weight is in front. So S2 is right here, which refers to Jane, 120, S3, and S1. We're doing the same thing by reference as well, where we create the references of the objects and store them in a sorted order by their weight value. So S2 is here, S3, and S1. And notice that with the reference approach, we are referencing the original object inside each of the elements in the list. Let's look at what happens when one of the objects changes. In this example, let's say S1, which is Doug. He goes on a diet and loses 105 pounds. So his weight changes. In the copy approach, there's a problem because the weight change is not reflected in this list. Therefore, you can make any changes to an object. The same object stays the same, unchanged. This is a problem because now you have an outdated snapshot of an element inside the list. Let's look at the by reference approach. The good news about this is that if Doug's weight changes, that value would have been changed as well inside this list. Because remember, S1 is stored inside this area, and that object refers to the same object as on the outside. So this is all good. However, our list references is out of order because Doug, instead of being at 230 pounds, he's at 125 pounds. So again, there's pros and cons with either approach. Let's talk about which approach is better. In looking at the pros and cons, let's say if time and space is of concern, and most likely they are, then maintaining references is definitely better than maintaining copies because the latter involves time and space to create and maintain references. Since you're referring to the same objects over and over again, you don't have to worry about spending more time and space to create them. On the flip coin, if both time and spaces are not a concern, then making a copy actually gives you a lot more control over the access to and integrity of your ADT. That's it. If you want to make a rigorous deep copy facility inside your code to completely control every single properties and attributes, mutable or immutable, by yourself, and you have a lot of time and resources to maintain and sustain your application, making use of this ADT, then yeah, by all means. So as to which approach is better, it depends. Just remember, with use of either approach, you must be very careful about the changes you make to the data, which is central to maintaining the integrity and consistency of your application inside any ADT, not just collections. This completes our discussions on how best to handle data inside an abstract data container.